Hi, this is our Intelligent Notes final presentation.
Hello, my name is Aryan Sharma, and I'll be doing the introduction to our Intelligent Notes system. Intelligent Notes is a note taking application designed for smooth note taking, organization, and combining minimalistic UI with collaborative features and using AI to assist with the tagging and summarizing of notes. Many people ask, well, what's the point of another note taking app because there's so many out there? A lot of them lack advanced features, including streamlined organization and seamless communication. The whole point of Intelligent Notes is that by using AI, by using smart organization and innovative collaboration, we are able to create a very streamlined organization and a very simple way of doing note taking. And a really important point to make is that it is very easy and accessible for people even of older age, people that are not used to using um, apps like this, or people that are just not super accustomed to technology, but it still has the advanced features that would be very useful for someone that has been using technology for a very long time. It would be great for them for their note taking and be able to further advance that. So that's really the main purpose of this, is to create a really good balance between a new person that just started using technology and a person that's been using technology for a very long time by using AI, by using newer features that are not something that's been done before. And by using this, we've created a very innovative product that will be the most unique note taking app there is on the market.
I'll be going over the requirements for our intelligent note application. We've broken this down into three key areas: functional requirements, non functional requirements, and software requirements. So let's begin with the functional requirements. These are the core features of our app that needs to deliver in order to work properly for our users. We first have the note creation, which is the backbone of our app. Users need a simple and intuitive way to create notes quickly, and this helps with that. Then we have our note organization, which basically allows users to organize their notes into folders, which helps them stay structured and find things easily. We also have our AI powered organization, which basically means that the app can help automatically sort or even suggest categories based on the specific content of the notes. We then have our smart search, which is another key features, which allows users to find specific notes using keywords or even tags, even if they don't essentially remember the exact title. We then have collaborative tools, which lets users share notes or work on them together, which is great for group projects. We then have our user-friendly design, which is very essential. This interface is very clean, it's easy to use, and accessible to all users of all levels. Moving on to our non-functional requirements. These aren't really specific features, but they're just as important. For our performance, this basically means that the app runs smoothly without any type of lag, especially when there's many amounts of a large amount of nodes. Then there's reliability, which ensures that our app doesn't crash and that the user's data is safe and available whenever they need it. Then we have usability, which focuses on how easy it is for users to interact with the app and learn how to use it. Lastly, we'll talk about the software requirements, which is very important for our development and for running the app. This app was built using Java 11 or higher. We used Maven for building and managing project dependencies. A minimum of 4 gigabytes of RAM is recommended for smooth performance, and you'll need at least 500 megabytes of free disk space, plus some extra depending on how many notes and attachments you will use. These were our requirements, which helped guide our development process and ensured we created a functional, efficient, and user-friendly application.
Intelligent Notes follows a classic client-server architecture with three clearly defined layers. On the client side, we present the desktop interface, which is simply the part users click and type in and interact with. The server hosts all business logic, including authentication, multi-user coordination, and any AI-driven features. Lastly is the storage layer, which is the repository for notes, folders, tags, user profiles, and different version history. This separation ensures that the interface remains fast and focused, while the heavyweight tasks are concentrated in a secure and scalable backend. Here we have our complex class diagram serving as a blueprint for our system. The client tier is intentionally lean. Intelligent Notes app boots the UI while folder management component manages navigation and note editor component handles the text editing plus any AI assisted actions. Whenever someone saves, searches, or requests a summary, These two components invoke one of two service interfaces of the server. Storage service orchestrates every persistent task and is backed by file system storage service, which writes structured files. AI summary service delivers text intelligence. We route to cloud AI summary service for cloud grade output or local summary service for offline and cost sensitive scenarios. Centralizing these services lets the server enforce authentication, role-based permissions, real-time collaboration, and version control in one place. Data including folders, notes, tags, user profiles, and history is stored to the same service door, simplifying backup and history examination. The system follows three key principles in order to make a successful and streamlined program. Separation of concerns keeps the UI, logic, and data isolated. Dependency inversion means the client depends only on interfaces, enabling hot swappable storage and AI engines. Lastly, single responsibility ensures that each class remains small and testable.
For our implementation, this program was written in Java using Maven and the JavaFX framework. The model package contains classes folders, notes, and search results, where folders can contain notes and search results utilize contents that are in folder and notes. The service package contains the storage service interface. The file system storage implements this interface and is used for the folder hierarchy. The AI summary interface for content summarization, and the Claude AI summary service implements this, and so does the local summary service. The UI package contains the Intelligent Notes app, where the main application class is run and has the primary UI layout. The folder management component is the tree-based folder navigation panel, and the note editor component provides the rich text editing for notes and includes autosave. One important thing is folder and subfolder storage for notes. So we implemented a hierarchical data management system. Folder hierarchy system implements recursive data structures where folders can contain both notes and other folders. The application persists this hierarchy using a directory-based approach in the file system storage service, where each folder is represented by a physical directory containing JSON files for notes and metadata. Here is a sample code showing the folder class and its methods for adding a subfolder and adding notes. Next, we have the AI integration and local summary fallback. Claude AI is used as a default API. The implementation includes a fallback for local summary for when the API is unavailable. So there is an option in the settings to copy and paste your API key into the input, and if that API key is there, then it will utilize the Claude AI class, and if it's not, it will use the local summary. And these are two code snippets. The left one is just a sample of the request for the API, and the right is a method for natural language processing that extracts the first sentence, the middle, and the last sentences, and you can adjust how many sentences are taken out of the notes. So if it's more than 3, you can add as many sentences as you want for the local summary. Next, we have full text search implementation. This allows efficient search across all notes and folders. The implementation includes context-aware previews that highlights the matching texts in the search results. Here's a code snippet of methods for searching the notes and for searching in folders, and it also recursively searches in subfolders. Next, we have full text editing and autosave. The note editor uses JavaFX's HTML editor for rich text capabilities and implements an autosave feature, which is triggered 2 seconds after typing ends. Here is a code snippet of the schedule autosave method. You can adjust how much time it will autosave in the program. Some features that were not implemented in our demo include multi-user editing, AI keywords and tags, and AI organization of notes. We would like to, in the future, build on this program and implement AI for keywords and tagging. So it'll take the note, it'll look at the content of the note and pick out the most relevant keywords and tags and list them. For AI organization, it would be great if you could upload a series of notes and the AI can organize them into folders for you.
Next, we move on to test cases, where the following test cases listed below were run in order to confirm the intelligent note system's dependability and functioning. A description, input, intended behavior, and result type, whether positive or negative, are all included in each test. The first few tests focus on the basic user behavior that would happen when interacting with the system, so being able to create a new folder and new note, and making sure they're appeared, which passed. We were also able to make sure we can remove notes, modify a folder's name, also passed. The next few items have to do with search and summary. For example, being able to use the search function with the keyword test, showing both in the title and the body of a note, as well as the ability to summarize a note and have the AI-generated summary be automatically created. We also wanted to test to make sure that for an empty note, the summary wouldn't contain any AI-generated hallucinations. So we made sure that summarizing an empty note by accident would display either a message or an empty summary. We also test the user's ability to drag notes into different folders, summarize a folder overall to get things like the number of notes as well as common themes, as well as to summarize using local summary rather than the API key. Additionally, we want to make sure the user can delete the notes folder if necessary, as well as using HTML for more advanced formatting within a note.
This is our Intelligent Notes project demo. When you open the program, this is what you'll see. First thing you can do is you can create a folder. We can call it test folder. And in that folder, we can create a new note. And here we can change the title of the note. Hello, this is my test note. And inside we can write the contents of the note, contents of my notes. And it will automatically save 2 seconds after typing ends, and you can also save it manually. You also have buttons here on the folder section that also will create a new folder, create a new note in that folder, and delete with a confirmation delete. You can delete notes, and you can also delete folders. Here I have some note examples. You can add links, and you can add images to your notes. This is a note about the functions of the liver. And let's say I want to find all instances where the word blood appears in my notes. So I can come here and I can search, and it'll show all the notes that contain that word, and it will also redirect you to that note. Next, I'm going to show the AI features. So here you can input your API key. In this case, it's only compatible for Cloud API, but in the future that can be changed to implement other types of AI API keys. When this key is saved, it will save it for future use, so you don't have to input it again. As an example, I'm going to create a folder for my summaries to show them side by side. So first I'm going to summarize using the Cloud API. I'm going to summarize the kidneys note, and this is what it gave us. So this is going to be the Cloud AI summary, and it looks like this. Next, I'm going to show the local summary. In the case where you don't have an API key for an AI, you can use the local summary, which extracts sentences from the notes using natural language processing. So what I'm going to do is I'm going to delete the API key. I'm going to save, and it's going to tell you it's using local summarization. So now I'm going to go back to the kidneys, and I'm going to summarize it again. And this is what it'll give me. As you can see, they are different. The local summary extracts text directly from the notes, while the AI summary provides you a AI summarization. One thing that you can also do is you can summarize entire folders. I'm going to input my API key for that. I want to summarize the entire anatomy folder that includes the liver, kidneys, and pancreas. So I am going to right-click on it and summarize contents. Here is the full summary. So it tells you a summary of the notes. It goes into each note and provides bullet points and gives you a conclusion for the summary. There's also the same feature for the local summary, taking out the API key, saving, and doing that again. It will just provide a very brief summary of what contents are included in the notes. So it will tell you how many notes are contained in that folder. its common themes, and the names of the notes in that folder. Thank you so much for watching this demo.